Just a minute. See my Wi-Fi. It's very slow. Am I audible, Zaid?
Mm-hmm.
Okay, so just a recap for yesterday.
Mm-hmm.
What we have seen in Unit 4, we have started with the concept of probability, and we have seen the general rule of addition of two events. Okay, so what was the
Mm-hmm.
general rule of addition? Just we'll revise and start, jump on to our next topic, general rule of addition, general rule of addition of two events. Of two events. It can be for many events also. Many events also. So what will be probability of A plus B? So it will be probability of A plus probability of B minus probability. What he has given in the textbook, this we'll see first one time. So he has given the intersection. No, not union and here what he has given. A and B. Okay. A and B,
Mm-hmm.
probability of A and B. And I have told you, I'll make this as or, and or corresponds to A plus B, correct? This is equals to probability of A plus probability of B minus and corresponds to intersection A intersection dash. Is it clear? So this was the general rule of
Mm-hmm.
addition. Then we had seen this on is this on Venn diagram also. So first of all, we have completed with the general rule of addition. So please see this example. We have completed the example yesterday.
Yeah.
So many probability problems involve simple computation that you cannot do on your calculator. It may be tempting to just write down your final answer without showing the supporting one. Don't do it. A naked answer, even if it's correct, will usually be penalized on a free response question. What happens if you use a general rule? Okay, so I've showed you how to use the general rule, and if, for example, if if A if A and B are disjoint. Disjoint. Again, I am writing, repeating the terms which are similar in meaning. Mutually exclusive. Mutually exclusive. Exclusive. That is the thing. Mutually exclusive. So disjoint is exclusive. Then, probability of A intersection B. That means there is no element in common. It will be zero. So the formula will become probability of A equals probability of A plus B equals probability of A plus probability of B. This was the general discussion, and we end it here for this topic. So we have completed. So next, what we will see is this example. Have we done this example, Zaid? Yes or no? Giving it for homework.
Mm-hmm.
Shall we do it now?
Yeah.
Okay, we'll do it. So this type of example we have done is it will be more interesting if we cover it here. Okay. So Yellowstone National Park staff surveyed a random sample of 1526 winter visitor to the park. They asked each person whether they belong to an environment club like the Sierra Club. The respondents were also asked whether they owned, rented, or have never used a snowmobile. The two-way table summarizes survey response. Okay, so we have done this example in the previous chapters, if you remember. This environmental club and they have used or not. Okay, so suppose we choose one of the survey responded at random. What's the probability the person is an environmental club member? So what is asking the probability for suppose I'll design an event A. This is showing problem. See. So A is such that the person is an environmental. The person is an environmental club member. Club member. So your question comes: what's the sample space? So sample space is the whole staff. Yellow National Park staff surveyed a random sample of 152. So the sample space is 1526 winter visitors to the park. Winter visitors to the park. They are the sample space. That people are in the sample space. So what we have designed the first event. So in the what will be the probability of the first event? So see here one more thing. If I want to write the number of elements in A, so how do I write? See, this n represents number of elements. This bracket represents of. This bracket represents of, and this represents A. So number of elements of A. So how many elements are there in A? So the person is an environmental club member. So environmental club member, yes. So how many people are there? Sorry, we need to plus it also, no?
Let's see.
Yeah. Sorry. No. This we need to plus this also. See, we have not find the total
Mm-hmm.
probabilities. So what will be the addition? 13 to 15. 5, 1, 1, 2, 2, 7, 9, 9, 1, 10, 0, 1, and it's 3. So the total number are 305. Yes or no?
Mm-hmm.
So what will be the probability of A? It will be number of element in A upon number of element in S. We also write like this also. Huh? So how we'll write number of element in S? I write a comma here and number of element is S equals to 1526. 1526. So it will be 305 upon 1526. 305 upon 1526. So we'll use a calculator. 305 divided by 1526. It is around 0.1998. So it is around 19.98%. Got that? Yes. Then now the second question
Yeah.
that we need to answer is find the P, not a snowmobile rental. So not. I have told you when positive, negative something comes, not a snowmobile renter. Okay. So what? How we will find the probabilities? Is not. I've told you one minus probability of snowmobile renter. Okay. So I need to find this one minus probability of snowmobile renter. So I'll need to find this one first to find this. So probability of snowmobile renter. So how many people are there in snowmobile renter? We'll come to your snowmobile renter. So add this, both of them. So it will be 7 plus 7, 14, 1 carry, 16, 7, 1 carry, 5, 574. That's the thus. So 574 upon 1526. So I'll
Mm-hmm.
574 divided by 1526. Are you getting that? So it was 0.3761, which is equal to 37.61%. Right. Was the
Yeah.
P environmental club member and not a snowmobile renter? That's a very good, interesting question. What I'll do? See, we have done this thing there. No? I'll copy that again because that's very crucial question by my side because you need to understand what he's mentioning here. We know that there are two things here. Uh, P is environmental. P is environmental club member and and corresponds for intersection, and not a snowmobile rental. Snowmobile rental. So that's a big task.
Mhm.
So means what? For suppose A snow mobile renter, for example, and my B is snow environmental club member. Sorry, environmental. Change this.
Mhm.
Environmental club member and snow mobile renter. So see this what he has given. We need to find probability A, and means intersection, and this not, it's not means opposite. So it's B complement. Yes or no? Say
Mm, yeah.
yeah. So we need to find this. So from the table, it is very easier in the table. So we need not apply any formula. Environmental club member. So where is environmental club member here? See, environmental club member. Okay. So it is
Mhm.
environmental club member. We fall in this club. Now we see and not a snowmobile renter. We do not want snowmobile renter. So leaving this, we are considered about both these two columns. So first, what we'll do, add this, this one and two. Yes or no? So how much is the addition of this? Because we need environmental club owner. This one is fixed first of all, and then in this column, these two are fixed. This one and this one. The rental one is cut out. So
Mhm.
6 plus 2, 8. 1 plus 1, 2, 228. So it will be 228 upon 1526. So
Yeah.
it is
Okay.
228 divided by 1526. So it is around 0.159. 0.1494, which is around 14.9. Got that, say? Yes or no? Interesting. Find the probability that a
Yeah.
person is not an environmental club member or is a snow mobile renter. So we need to find the intersection here, no? By the way. And he has given there, no? For example, this solution is wrong for this. He's telling us add. Yeah, and this is the whole union. This what we have find is the whole union. This we have done wrong, by the way. Well done. What we are doing, we need to find this correct. See here, that's correct. That we are finding, we need to find this. But for finding this, what we are getting is A union B complement. So it is 228 upon what it will be 1526. So it is 14.49%. So for finding A intersection B complement, what we need to do, probability of A plus probability of B complement minus probability of A union B complement. 4 minus 4. Yes.
Mhm.
What it will be probability of A? Probability of A is it is a what environmental club owner. So how many environmental club owners are there in total? We have done it. Environmental club. How many are there? We have done this in previous edition. Environmental person is so it is 19.98%. So it is 19 point. This we have done it for 19.98% plus not and what you say renter. We have done that also. Not a snowmobile renter. See here, he has done this. So it's not a snowmobile renter. It is 1 minus. Oh, we have not performed 1 minus here, which will be equal to 1 minus 37.61%. So the final answer will be 37, 38. 38 left is 40, 60, 2.29. 29, correct? Not 39, 39%.
Mhm.
So it is 62.39%. Plus 62.39% minus 14.49%. So what will be the final answer? We see it 19.98 plus 62.39 minus 14.49. So it's around 70.88. Yes or no?
Mhm.
That's the final answer. Got that, say?
I got
Yeah?
that.
Yeah.
Yeah.
Last question, you can do it on your own. It's easy.
Mm-hmm.
Now we'll move on to the next thing. That's the Venn diagram.
Okay.
Ah, just nothing.
Mm-hmm.
So what's a Venn diagram first of all? So what's a Venn diagram? The representation of events or sets in the form of diagrams. In the form of diagrams
Mm-hmm.
is called as a Venn diagram. Is called
Venn
as
diagram.
a Venn diagram. Yes. Why Venn diagram? Because so I'll write the question. Why the name Venn diagram? Why the name Venn diagram? Any guesses? Because the
Um.
scientist, because the scientist or the researcher, you can say, scientist or researcher who invented it, who discovered it, who discovered it, had name Venn. Had a name means his name was Venn. Therefore, it is termed as Venn. Is it okay? Yes or no? So there are
Mm-hmm.
two
Yeah.
rules by the thing. What I have explained you further in the Venn diagram. Rules you need to remember.
Mm-hmm.
Always there is a square box. Square box always represents a sample space. No other shapes. There are two shapes that can be used generally. A square box for sample space and circles, as much circles as you want, how many events you have. And circles are used for events which are which are inside the sample space. Got that? Right? Or generally a Venn diagram
Yeah,
is.
got that.
Yeah. So we'll see the definition of the textbooks as well. So see, this is the so see, this is the whole A which is covered in yellow. This is the whole B which is covered in what do you say bottle green. Bottle green or what's the color you can define it as bottle green or green. It's green. Okay. And you know this common point. What I'll do, I'll mark the major points here. See,
Mm-hmm.
this region, this intersection. There may be this region or there may be not. If there is no any common point, the diagram looks like this. This is A, this is B, and this is SS, means the sample space. If there is no common point, here in general he is giving a general diagram, means there is some common point. So this region is known as A and B or A intersection B. This sign is for intersection, means common part, common part for both. Okay, and what is you will say A or B? A or B? What will be A or B or I'll write A or B next now in the next diagram. See A or B. This the whole thing. This whole thing. I'll shade it. This whole thing will be called as A or B, or you can write it as A union B. I'll write the wording here. A union B. That got that thing? Yeah, that's easy. I think.
Mm-hmm.
So Venn diagram consists of one or more circles surrounded by a rectangle. Each circle represents an event. The region inside the rectangle represents the sample space of the random process. Got that?
Mm-hmm.
I think there is no
Yeah.
confusion. So this here is telling is that two-way table. We have seen this two-way table further also. This one, this
Mm-hmm.
this he is that was a topic where he had listed that in the earlier stage. But we have seen this. That's the reason I am not explaining here. When we had started this topic, that started with the heading of two-way table only. It is upside, so it was a C at the end. It is two-way table, correct? So two-way table, and that was that table. Okay. So now we'll look how to represent two-way table on the Venn diagram. See, so this is a two-way table. This is
Mm-hmm. Okay, that's a two-way diagram table, the one that we did
correct.
before.
The whole sample space, or suppose is of what you say 178. Yes, yes, correct. 178 R. So now we need to distribute them into two parts generally. For suppose it is gender based on the gender. How we have shown we'll see first. So the Venn diagram displays a sample space in a slightly different way. There are four distinct regions in the Venn diagram. These regions corresponding to four non-total cells in the two-way table as follows. See how we have given. We can give it
Mm-hmm.
on male
Yeah.
and here. We can draw different things in different types also. Not a problem there. We'll take this also on. It's upon us what to give, which figure to give which name.
Mm-hmm. Just give me 1 minute, 1 second, real quick.
Yeah.
I'm back. No?
Okay, we're back. I'm also back. So seeing
Okay, you're
this
back?
diagram, yeah, also
Okay.
back. So seeing this diagram, he has given A for male. See,
Mm-hmm.
I was just fixing
Yeah.
this issue as A is for male. A he has given for male. Okay, so A complement will be female. Yes or no? Correct? Yes or no, Zaid?
Yeah.
Yeah. And B, Alhamdulillah, he has given for
Yeah.
pierced ear. So
Mm-hmm.
B complement will be not pierced ear. See,
Mm-hmm.
yes or no, how? You have don't have to give A, B, C, and D to each one of them, like male A, then female B, C, yes, D, no, like that. You don't have to give like this, okay? You just have
Mm-hmm.
to be very drastic and unique in giving the association of the event. So, what he has drawn here, see, he has given A. So, A, how many are there? 71. Male. Male, okay? Male are 71. Okay, and these are the pierced here. So how many total are the pierced here? See here pierced here. How many of them are total? Male, and
There's
how many of
about
103? See here 103. So
mm-hmm.
84,
Yeah,
84
103
comes
said
here.
yes, and 71
84
said no, and one's in between.
correct, correct. So 19
19 are in
is
between.
between. Correct. So which are pierced. So male and pierced are 19. So it is between, and not pierced, which are means female. So it will be here 84. And this four are female and not pierced. So here it's four. Got that, Zain? Is it easy or not?
Yeah.
Remember,
Yeah, I got it. It's
things come
easy.
inside. Number three things, three numbers comes inside, and the fourth one comes outside. So depending on their association of the variables, it's dependent on that. So that's you can generally make this table. What you say, one-way table from two-way. What you'll say, write those things there. See what I've told
Mm-hmm.
you. See, A union B, A and A complement. I've showed you in our this. Yes or no? This is A intersection B. I've told
Yeah.
you this is A union B, and A complement. I've showed you in the further class only. If see if this is what you'll say the whole sample space and this is A, then the space outside A will be A complement. Correct? I've shown all these
Mm-hmm.
things. So we have covered all these things. So the intersection, just we'll see the definition. Intersection and event. So the event A and B is called as intersection of events A and B. It consists all the outcomes that are common. Means what does intersection do? We'll take this. So what does generally intersection do? Intersection intersection generally sees all the common outcomes. Sees all the common outcomes
Yeah.
between two events. Between two events. Two events. That
Yeah.
okay. Yeah, and
Mm-hmm.
for the event A or B is called the union of the event. It consists of all the outcomes that are in A or in event B. Means union generally adds up. Union generally adds up, adds up, adds up all the possible outcomes Possible outcomes appearing in A and B. Appearing in A and B means what? I'll give you an example of, because when I write adds up, there is a general confusion in brain, but this should be not there. It's for something. So what will be A union B, by the way? A union B, it will be A, B and C. C, it is repeating two times, but I'll write uniquely because you know sets are unique, events are unique, the observations are not repeated. Yes or no? And what will be A
Mhm.
intersection B? So it will be only C. Got that? How to calculate the union B and A intersection B? Yeah,
Mhm.
is it
Yeah.
easy?
Yeah, it's pretty easy.
Yeah, so that again, this, see the general rule of addition or the general rule of union he has given in the form of union and intersection. Okay, so see,
Mm-hmm.
so he has given here intersection. Find the probability is showing us that this part gives us outcomes here double counted by the probability of A and B. See, this is double counted. What I've explained you further. So what we generally do, minus the intersection. Yes or no? Why we minus the intersection
Yeah.
one time? Because it is double counted in both probability of A and probability of B. So it's trying to explain this, which
Mm-hmm.
I've explained you very further. Yeah. So
Yeah.
we have done with section 5. We'll do this example. Read this. You have to do it and send me on the WhatsApp. I'm waiting. Okay. Do this and send me on the
Okay,
WhatsApp.
I'll try to.
Yeah.
Mm-hmm. Yeah. I didn't finish the chapter 2 test yet. I'll do it soon.
Yeah. You have finished the chapter today. So just for
No,
maybe
I
on,
did not. I did not do
did
it
not.
yet. I'll
Okay.
do
You
it
did not.
soon.
Okay. No problem. When you get time, just finish it and forward. Okay. Now do it. I'm
Uh-huh.
waiting. I want to see the solution of this.
Uh-huh.
We'll discuss your solution later.
Okay. Yeah. Hello?
Okay. Then, yes. Have you done it?
Okay. Yeah, you're there. Okay. Hmm. Yeah, I can hear you.
You can hear me.
I the WhatsApp. Yeah.
You have shared it. I've not received it yet.
Okay, yeah.
You received my salam.
Yep. Okay. Ready?
Yeah, send me.
What?
You
Oh,
have
the
done that
message
example?
bar.
No, you have
Uh,
done this
uh,
example. Okay, so come on, give me the answer. Make a Venn diagram to display the sample space of this random process using event F, using uses Facebook and I using Instagram. Find the probability the person uses
uh,
either Facebook or
yeah.
Instagram.
So
That
43% do both.
correct.
No,
See,
43% do the first one. Then the both is 25%, and the no is 3%.
correct. And 29% is not good. Okay,
Neither.
right. Correct.
Yeah.
Okay, so that's all the thing that you have made the table. See, he has given first of all you have calculated all the probabilities from the Venn diagram. Then it helps us to draw the two-way table also. Yes or no? See how he is drawing the two-way table. It's very crucial, by the way. There can come a question that draw two-way table. So we have finished with section 5.2 and we have seen a probability model, sample space, and all other things there. Shall we do one example here, or you try that as well? Wait, I'll see something about an example. Come on, do the first one, 31st one.
Okay.
Tell me the answer.
Okay. Yeah. Okay. Got it.
Okay, you are done.
Yeah.
So give a probability model for this random process. So I'll read the question. A four-sided die is a pyramid whose four faces are labeled with the numbers 1, 2, 3, and 4. See image. Imagine rolling two fair four-side dice and recording the number that is showing at the base of each of the pyramid. So you are recording the base of the pyramid. Okay. For instance, you would record as 4 if the die landed as in figure 4. Okay. What you have to do? Take this question by the way. Question one. See, so there are two dices, pyramidal dices. The number that comes on the base, for example, 4 here come and here comes on the base is 5. So you'll record you record it as 4 comma 5. So it is a four-faced die. Okay. So what will be the general observation? Can be sample space. We'll write down first as you have to draw the probability model. So in a probability model, there must be a sample space and we have to give a statement that the occurring of each of the what you will say outcome in the sample space and equal out is equally likely means have equal probability. So 1 1 1 2 1 3 and 1 4 because it has maximum 4. So like this it will be 2 1 2 2 till it will be 2 4 correct and it will go on to 4 1 and this will go on to 4 4. So how many elements will be there in sample space? Number of elements in sample
16.
space 16 correct? Yes 16. So
Mm-hmm.
you can write in the statement, therefore it is a probability model. It is a probability model with each outcome with each outcome equally likely, having probability 1 by 16. Yes or no?
Mm-hmm.
Correct. So define event A getting a sum of 5. So A is the event getting sum of 5. So getting sum of 5 on the downward phase. So what will be the, what do you say, outcomes? So see this here.
One
It will
four,
be this
1 4 4 1, 2 3
2
3
3
2.
2 3 3 2. Any more? No.
Uh,
So
no.
it's so we'll write down first 1 4 4 1 2 3 3 2 and 3 2 3 2
That's it.
and what, that's it. So what will be the probability of A? Probability of A, it will be 4 upon 16, so it's 1 by 4, which will be 0
Hmm?
0.24. Yes or no?
Yeah.
So, gone. No, probability model you have done. Do one more
Mm-hmm.
example of that. Yeah, that is. Let me dance.
Have you the answer?
Yes, you have done the answer. Yes, you tell me the answer. Come on. First one. Let me read the question first. Let me dance.
What's the valid probability model?
Is it a
Or the
valid probability
like?
model? Yes or no? So what we need to do, we need to verify that every outcomes probability is between 0 and 1. So is it there? Yes or no? Yes. So
Mm-hmm.
that's correct. And the second thing, we have to verify that add all the probability of all the outcome and see it is coming 1 or not. Not less than or not greater than. It should come exactly 1. So 3, 2, 5, 5, 6, 11, 11, 9, 20. 2 carry. 2, 2, 2, 4, 4, 6, 4, 6 is 10. 0, 1 carry. 1, 1 carry here. 1 plus 0, 0, 0 adds 1. So it is a valid probability. Yes or no? We have verified it. Correct?
Mm-hmm. Yeah.
Yes. Next, what's the probability that the chosen person's mother tongue is not English? So not English, what it will be? Say,
Uh, it'll be 37.
very good, Zain. Very good. Good. That's right. Next,
Mm-hmm.
what is the probability that the chosen person's mother tongue is one of the Canada's official language?
9.
So, what is the question? Canada has two official languages, English and French. Okay, so you need to find the probability of English and French. Yes or no? English or
Yeah,
French?
but
English
Canada's
or
it's
French?
other.
E or F. So what we need to do, probability of E plus probability of F minus probability of A intersection F. Yes or no, Zaid?
Mm-hmm.
So yes, and you can see that there is no, they are disjoint. So just we need to do probability of
Mm-hmm.
E plus probability of F. So it will be around F. So it will be around 6 3 plus 2,
80.
5, 85. That's right. Got that right?
Yeah. Yeah.
So we'll stop it here today for today. So
Mm-hmm.
you can practice this example. See, there's 1 2 way table also, and send me on my WhatsApp by doing the homework. See, 41. Mark it down. 41. You have to do it and
Mm-hmm.
send me on my WhatsApp the solution. Okay, and solve the paper
Okay.
also that I had given. Tomorrow,
Okay, got it.
inshallah, we'll start with 5.3. What's all on 5.3? See, probability on a higher version. Here you'll see some higher version probabilitical concepts, likewise conditional probability and independence. So what is conditional probability? I'll just give you an introduction. Means there is some condition based on the event. And if this condition is fulfilled, then only the further condition will be fulfilled and we'll take that outcome. If the condition is not
Yeah,
fulfilled, then we
okay.
cannot take that specific outcome with that. So we'll
Yeah,
see
okay,
how.
got it.
So we'll, inshallah, see. So we leave the
Mm-hmm.
class. Assalamu alaikum.
Walaikum salam.